Does this work? Nice, it works. Dobro dan. Thanks for being up already that early. I like in Belgrade, like you guys know how to party. That resonates with my lifestyle. But yesterday I was kind of serious because I had my talk here today. So, but yeah, let's go into it. Yeah, my name is Simon or Simon, or I think in Serbian you would say Simo, no? Yeah, okay. So I don't care about the pronunciation actually. It's just yeah, Simon, Simo. And today we talk about the graph, or like unleash the graph's data. It's a little bit the marketing title. The more nerdy one is like we talk about the idea of subgraphs as read-oriented rollups. So does this work? A little bit. Okay. Cool. Let's get into it. So who knows what is the graph? I do. Yeah. So most people, nice. Okay. So the graph, like simply explained, nice. It works this time with the animation. Is yeah. It's just like takes all the data from different blockchains and also from off-chain data, and then brings it, organizes it in an easy way, so it's easily accessible. Or we can also look about the architecture of a dApp. So we have the front end on top. The idea here is like that's a decentralized front end, so it's maybe distributed with IPFS or Arweave. And then we have the subgraph that sits in between the front end and the contracts which are on the lower level, and the contracts have the blockchain data. So that's roughly the system architecture that we want to say. So that's actually is then the data layer of Web3, kind of the big claim here. And it's true, I mean, it's like a decentralized data network. It runs since 3 years already, or even a little bit more. Like, as of now, I think I had to send in this presentation a month ago, so like these numbers changed, but like there are 107 indexers, 64,000 delegators. That number went up a lot since we transferred the protocol contracts from mainnet to Arbitrum. So it's much cheaper to be a delegator, so much more people become delegators. Everybody can be a delegator, so look into it. There are also 732 curators and the subgraphs. That number goes up now very fast because like on the 12th of June, the hosted service, which was a centralized offering to demonstrate product market fit of subgraphs, will cease to exist. So if you have any subgraphs and you're still using them, or use any subgraphs in your application or your data science stuff, then please upgrade. You can talk to me, I'll help you upgrade. As of now, 3.57 million query fees were generated or like sent through the graph network. It's roughly $1 million with the current prices. So that actually gives a truly decentralized data. So like the graph network is maybe if you want to drop a buzzword here, like what is it, DPIN, decentralized public infrastructure network, that actually works. And it all builds on top of subgraphs. And we want to kind of like go into this like what are subgraphs, how do they work, and why can we think about them as read-oriented rollups? Okay. So what is a subgraph? Simply said, let me try this again. On top, we have the database. So a subgraph defines a database schema. Then we have a mapping that says how to fill that database schema according to the data that we see on-chain. So think about just a database and instruction how to fill that database with on-chain data. So that's basically it. So what happens then is like that on the blockchain, we have all these transactions from all these different protocols lined up, and we share the block space, right? I mean, at least on L1 and on the big L2s, we will see where it goes with all these step chains. But this is kind of a little bit the reality that we share block space, all the different protocols. But what we need is kind of like a dedicated view, like that we just look at one protocol at a time. So this is what subgraphs enable. They are fully programmable. We go into that later. So the subgraph data flow, as I said before, we have blockchain data first, comes in, then it runs mappings in assembly script or Rust. Depends if you are in subgraph or substreams land. Then it writes to the store in a database. We can also read from the store, and in the end, we can send out queries to the customer. So that's roughly how it works. The cool thing about assembly script and Rust, there's a lot of magic in it, right? These are Turing-complete languages. I don't necessarily need to explain Turing completeness here, but I think you can think of it, you can do whatever you want. like they're fully, yeah, whatever. Like, so for example, one of the side projects that I worked on with some artists was to have a synthesizer that runs in the mappings of a subgraph. And then according to, I don't know, like the block hash of the NFT that get minted gets audio generated. So you can do crazy stuff like this. But also, this idea that came out already 3 years ago also, kind of this idea of like, say, hey, we can basically just use the graph because like there is this determinism. Each subgraph is clearly defined. Basically, it's a mini blockchain, so we just put very small stuff on chain, and then like all the computation happens on chain. So that has created this so-called data edge smart contract, which basically is just similar to rollups, right? They also just store some state on L1. We could have that data edge where you can actually store whatever you want into the blockchain, and then we can use something like the graph to index it and then even make sense out of it. So what happens is that logic moves from the blockchain or from smart contracts into assembly script, if that makes sense. So this also this thing, like moving logic or computation outside of the blockchain into another system, that's also now has like a lot of new ideas around, and then it goes into this AI co-processing. So there is another core dev at the Graph Semiotic who looks into this co-processing a little bit more. I explained the idea with subgraphs as they are something that's already used. But if you're interested in this thinking, check out the graph.com blog. There's a lot of talks about now how that works with the co-processing and so on. Okay, so we talked about on-chain data and Turing-complete mappings, so that we can move logic to outside off the chain, so to say. But we also want to maybe have some off-chain data. When you think about off-chain data, it's everything that exists that's not on-chain, maybe. But what is interesting, and maybe also like to frame it a little bit, what would be something that I want to publish or someone wants to publish, could be airline, free seats for airlines, and maybe want to publish this somewhere. I mean, currently I know there is some, I think Amadeus or some centralized service that kind of is in that market, but we could theoretically think about just publish all of it on in a Web3 way, right? We can think of free hotel seats, pretty similar. But also an interesting example would be with weather stations. So we have a decentralized network of weather stations, and we can put that data on chain and then run computations. And then actually an example that we do at EdgeNode is server data. So like access data to a server, we can also then publish on chain. So how would it work? So the idea roughly is we go in the same steps, but now the mappings not only have access to the store and the blockchain data, the mappings also have access to IPFS or RWIF data. And that's actually very simple. So someone just uploads that data, let's say on IPFS, takes the IPFS hash, and then puts it back on chain, and then we have a subgraph that indexes that contract, get that one, and then it can start the download from IPFS. So that works actually pretty well. And with that, as I said, we came up with this, or like the data science team at EdgeNode came up with this so-called quality of service oracle. So when people send queries to the graph network, they go through gateways, and from the gateways then to indexers. So the gateways actually know which indexer is fast to respond to which query, to which query actually, and that's something that's important that we want to know in the ecosystem, like which indexes are actually performing well. And how that works is like the logs are then piped out of the gateways into Red Panda and materializing. I mean, like that's some data science stuff that I don't really understand. But where I understand it back is like when it goes on-chain. So then they publish it to IPFS, and then they use OpenZeppelin triggers to put it on Gnosis chain, and on Gnosis chain it gets indexed as a subgraph, and so now we have a quality of service oracle. So whenever you kind of want to know which are the highest performing indexes, which are the ones that have the quickest query response times, and so on, there's a subgraph for it. You can create it on the graph network. The other thing that I said is more like a hypothetical thing. It's like if you would think about weather stations, so that could be like a DP network of independent weather stations. Everybody runs that at home, maybe get some tokens to run it, blah, blah, blah. But they all upload their data onto IPFS or RWeave, gets anchored back on chain, and could feed maybe then, that we go later, into an oracle that would be like, I don't know, you create an open air here in Belgrade, and then you want to know on-chain if it rained or not, because you want to trigger the decentralized insurance. And that might be a thing, because like if it's a lot of independent people that run these weather stations, then maybe we can trust the data more than it was just one agency that would give that weather information that could also be corrupted. I know, kind of a theoretical example here. But yeah, reusing the properties of the graph network that already exists, and as I said, already served that many queries. Yeah, as I said, like that's about monetization. So when you have data that we want to publish, usually it's a problem. That's why oftentimes public data doesn't get published, because then someone needs to have that API endpoint, and that needs to be rate limited, and maybe we need to have authentication. Maybe we want to have some billing on top just to pay our server fees and so on and so forth. But like with what I just said, is it's very simple. It's almost for free to publish that data and make it accessible, and then basically sell it through the graph network. Yes. So back on chain, as I said, like these both things, we have like these oracles for maybe weather and quality of service. We need to bring it back on chain, and that's actually something that already works. There are the gelato web functions, but also the chainlink functions that can get data from the graph network and put it back on chain. So there are different use cases. So for one would be like the one that just goes with on-chain data, that would do like complex computations across on-chain data that gets in the subgraph, then comes out with just one value that maybe, I don't know, let's say for a DeFi risk management thing that could be piped outside that one. Or, as I said, with off-chain data that we even get in weather data, and then we have an on-chain contract that can say, did it rain or not, according to that setup. So that would be the full cycle. And that's why that idea about roll-ups comes, right? It kind of like with roll-ups, we also want to offload computation state from L1 to make it cheaper and faster, but we also want to bring it back on chain, like or like back on an L1 for what concerns L1, so to say. So that's the roll-up thing. And when you think of subgraphs, as I said, then the data gets processed, and we can bring it like we can bring it down on chain if we need. Questions are later, but yeah, thanks for the contribution. Yeah, so then there's of course there's this question of verifiability. So the data that gets indexed currently, there is this proof of indexing going on. It is indexed when they see data, then they computate a hash on top of that data and put it back on chain to say like, hey, actually I indexed that data. They start to talk to each other, and although they compete, they also talk to each other. Did you see the same data? And yes and no. Should be very deterministic, you can think of, but interestingly it's not. Like different configurations of different Ethereum node or L2 nodes, then could be that sometimes an event gets missed, and interesting stuff like this happens, and we start to uncover it by having that system. And then also with the query, when we send a query to the graph network, each indexer responds with a query attestation and says like, I, with all my stake that I put into the network, guarantee that it's true, right? And then if that can be proven wrong, it can get slashed. There are fishermen, so there's this kind of game theory going on. But obviously, we want to move forward into more like strong guarantees, which would be verifying, indexing, and querying. And there's first steps going on, like simple data extraction from chain. When we get that Merkle roots up into that indexing layer, then we can start to have some checks. Unfortunately, JSON RPC doesn't really help with that, so there is this reinvention of data extraction going on that also other teams do, but like what in the graph ecosystem, it's done with Firehose, so we can have maybe these guarantees later on, and then like all these verifications then go layer on layer to be trying to work up. But that's future. And I think that's it already. You can scan my QR code, follow me on Twitter. My DMs are also open if you have any questions, but I'm also still around now for questions, and you can also try to find me, as long as I'm in Belgrade. Thank you so much.
So we have some time for a couple of questions. So if there's any questions in the audience, feel free to raise your hand. Don't be shy. Don't be shy. We're totally cool dudes.
There are no wrong questions.
I think the baby asked all the questions.
Yeah.
Like, it was a good question. Anyway, thank you so much, Simon, for being here, for sharing your knowledge. Give it up for Simon.